we are given the root of a binary tree and we need to flatten this binary tree. So flattening means converting it to a linked list, and the linked list should use the same tree node class that we are using in the binary tree. The right child pointer points to the next node in the list, the left child pointer always points to the null. And they say that the linked list should be in the same order as the pre-order traversal of the binary tree. So if we traverse this binary tree in pre-order traversal, it would be 1, 2, 3, 4, 5 and then 6. And we need to convert this to a linked list in the same order. So let's suppose this is our binary tree, and if we try to traverse this in pre-order traversal, it would be 1, 2, 3, 4 and then 5. And we need to convert this to linked list in the same sequence. So 1, 2, 3, 4, 5 and then each left pointer would point to null and the right pointer would point to the next element. So we can solve this using something called a reverse pre-order traversal. And reverse pre-order traversal is basically the opposite of pre-order traversal. So in pre-order traversal, we used to process the node, move to left and move to right. In reverse pre-order traversal, we'll move to right first, then move to left, and then finally process the node. So let us try run that and understand how the question is going to be solved. So let's start with the root, that because we'll just make the function call for root. So let's suppose we did the function call for root, and it will first make us go to right. We come to 4, we'll just move to right, and then we cannot because we'll just return back because it's null. So we'll move to left, we move to right, we'll return back, we'll move to left, return back. Then we are to process this 5, and to convert this 5 in this form, what we can basically do is we can make its left pointer point to null. That is sorted because the left pointer is always null. But what about the right pointer? Well, for the right pointer, what we can do is create another pointer called priv, and this priv would contain initially null. And what we'll do is we'll make the right pointer of this 5 point to whatever the previous is pointing to. So initially it would be null. Then we'll update the previous to now point to the current element, that is 5. So the current element is 5 and we'll make it point to 5. Then after 5 we come to 4. We make its left pointer point to null and the right pointer would point to the previous element, which in our case is now 5. We again update the previous to the current element, that is 4. After 4 we move to 1. It wants us to move to the left. We come to 2. It wants us to move to the right. So we'll just move to the right, we'll return back, then we'll move to the left. We'll come over here. We cannot move to the right or left because it's a leaf node. Then we'll process 3. We come to 3, we say that your left pointer would be null and your right pointer would point to the previous element, which is 4. We again update the previous element. After 3 we backtrack to 2 and we process this element. We'll say your left pointer would point to null because that's always there, and the right pointer would point to the previous element, which is 3. We again move this previous to 2. After 2 we backtrack to 1 and we say that your left pointer would point to null and the right pointer would point to the previous element, which is 2. Again we update the previous. As 1 is the last element in this reverse pre-order traversal, there would be no more function call. And if we look closely, this is the same structure that we wanted to return. So let's look at the pseudocode over here. So we'll just initialize the global variable called priv. Initially it will be null. We'll create the recursive function called flatten. It will take in the root, so the place where we started from, and this is the base condition. If the root is null, we return. This is what we were doing over here. If the root is null, we'll just return back. After this, we come over here and we say that we'll move to the right first, then we'll move to the left. We are following just the same sequence that we defined in the reverse pre-order. So first move to right, then left, and then process the node. How did we process the node? We explicitly set the left to null and we'll set the right to the previous element. Initially it was null, and then we update the priv for every step. So let's try this question on Leetcode. So initially we are going to create the previous pointer. So we'll say tree node type of previous pointer would be initially it will be null pointer, and then we'll come to this function. We'll say I will write the base condition. So if the root is null, then we'll return, and then we'll move to the right. So we'll call the same function, recursive function, to the right, and then we'll move to the left, and then finally we'll just process each node. So that would be we'll just set the roots left to null pointer. We'll move the right of this root to the previous pointer, and again we'll just update the previous. We'll just say update the previous to root, and let's try this question. And it says that there is an issue. Okay, sorry. So the roots right would be not okay. Submit the question, and finally we can do this. So this is how we can flatten a binary tree and convert it to a linked list using the preorder traversal.